one. Okay, we talk about the number conversion part 2. In the previous class, we have seen that conversion from any number or any radix to decimal number system. Okay, decimal number system. Why we have done this one? Any number system, the decimal number system, because humans are familiar with the decimal number system. That's only the reason that we can write. Okay, so humans are familiar with decimal number system, right? So what is the logic behind this one? The logic in this one is multiply the coefficients with their weights and sum them all. Okay, what we have done? We have done that. We have to multiply. Yeah, somebody's. Yes, we have. So what we have done this one. So for example, whenever we have a coefficient something like this, A0, A1, A2, A3, A4, something like this, 1 up to AN minus 1 and A minus 1, A minus 2. These are all coefficients, right?
Excuse me, sir.
Yeah, tell me.
Sir, Moodle ఉన్న లింక్స్ వాడమని చెప్పండి సార్. జీలాన్లో లింక్స్ వాడితే క్లాస్ స్టార్ట్ అవ్వలేదు.
No, you have to use the modules only. Don't use the Zoom link.
Glan.
Never use Glan. We have to use the modules only. Okay, please inform to all your known people. Okay.
Sir, can you share the WhatsApp group link, sir?
WhatsApp group link. I will share you that group link. You mean that this link you want to share it in the WhatsApp group or what?
Yes, sir.
Yeah, I'll share you the from next time onwards. Okay.
Okay.
For the timing, just ask them to join in Moodles. Okay.
Sir, I don't have the WhatsApp group, sir. I'm not in that group.
Okay. Somebody, can you help to that person? Saha, or maybe
yes, sir.
Sija, can you please give them some information for this video link, this Moodles link?
Okay, sir.
Are you there in the WhatsApp group?
Yes, sir.
Yeah, please please share that link. Please
Okay,
don't mind. Okay. Okay, so this is the number. Okay, so these are the quotients. We are representing all these are the quotients, right? These are the coefficients. Right. So if you want to get exact number, what I have to do is that, especially if you want to take it in the decimal number system, so according to the positions, we have to give the weight to that quotient according to the position. For example, this is the position number 0th position. Okay, this is the first position, second position, third position, fourth position. This is the n minus 1th position. It is minus 1th position, second position. Like this, we have a different positions are there. Depending upon their position, we have to give the weight to that coefficient. Okay, what is the weight to this coefficient? A0 is multiplied with what is the radix? For example, R is the radix, for example, to the power of 0. So this is what for this coefficient we are giving the weight according to their position, 0th position. Similarly, we have to add to the other coefficient with their weight, R to the power of 1. R stands for base radix, so it is valuable for all the things. Like this we have to do in all the cases. A minus 1, R to the power of minus 1, so on up to so forth. Okay, so therefore when you do something like this, whatever the coefficients that we have given, that will be converted into decimal number system. Okay, so that is what the logic here. Therefore, decimal number is now decimal number, or decimal number is nothing but what we can say that sum of all the things from I is equal to minus m to n minus 1 ai into r to the power of I, where I stands for the positions. Okay. Yeah, so I stands for positions. I'll write here where I stands for positions, R stands for radix, A stands for quotients. Are you agree with me? Quotients. So therefore, if you do something like this, for any radix R, that will be converted into decimal number system. That's what we have seen in the last class. Okay, now we go for today. Now today's class, we are going to look at now. Yeah, Niklesh has sent this WhatsApp group. Please take those who have required. Now what we do, conversion from decimal to any radix, right? Conversion from decimal to any radix. So, but it requires some kind of procedure. We have to follow some procedure. Okay, it's not direct, straightforward like decimal conversion, any radix to the decimal number system. We have to follow some kind of mechanism or procedure. So let us consider something like this. For example, number 1. Yeah. For example, 57 is the number in base 10. I want to convert it into radix 2. I want to convert it into radix 4. I want to convert it into radix 8. I want to convert it into radix 6. For example, something like this, I want to convert it into different radix. Okay, or different base system. So radix are based one and the same. Okay, now what I have to do here is that better I'll do one thing. Instead of saying that only one number, I'll take okay, for the time, for the one number I'll consider. Okay, 57 of base 10 to base 2. Follow the procedure. So I have to use the division mechanism. So whatever the number that I want to convert it into, so we have to take the number with the required radix. That means, for example, I want to convert the 57 into radix 2. Okay, then I have to divide this number with radix 2. Divide this number with radix 2. For example, if I want to convert the 57 base 10 into radix 4, for example, then what I have to do? 57 divided by 4 I have to write. If 8 means 57 divided by 8. If 16 means 57 divided by 16. Right? So therefore, what I can find from the division point of view, we will find that integer quotient. Okay, as we know that remainder is also there. And of course, we know that there is a quotient. So these are the things, right? We will get that from the division, right? So whenever you do some division thing, this is what we will get generally. These are the things that we generally get. So what we will get if you divide 57 by 2, what is the quotient here? Quotient is 28, right? That means 2 2s, 2 8s. Okay, that's it. So if you do like that, what is the value that we will get? What is the remainder? The remainder will be something like this. So 1 by 2, for example. So we will get the remainder is 1 by 2, right? If you sum up all these two things, it's a 57 only, right? For example, 28 into 1 by 2. So plus 1 by 2. What we will get there? 56 plus 1 by 2. So that is nothing but 57 by 2 only we will get there, right? Agreed? So that is what we have to do. Okay, so now what is the quotient I should consider? Here the quotient is this one we have to consider. So the 1 will be the quotient we need to take into consideration. This is the one information, required information, right? Similarly, if I take 57 by, now what is the remain quotient to what is the remaining thing? 28. We have to take divide by 2 again. What is its value? 14. అంతే కదా 2 1s 2 4s. So what is this reminder? 1 by 2. Sorry, not 1 by 2. It is 0 by 2. If it is 0 by 2, what will happen? 2 14s are 28 plus 0. 28 by 2 only it will be. Okay. Now what is this quotient now? 0 will be the quotient. So we have to take the 0 will be the quotient here. Getting? So next, what we do is that 14 is there. So 14 divided by 2. 2 7s, right? So what is the value of this one? 0 by 2 only here also. What is the quotient here? 0. Now again, 7 is there. 7 by 2, right? 7 by 2. What is the quotient value?
3.
3. 1 by 2. Therefore, 2 5s are 2 3s are 6. 6 plus 1 7. 7 by 2. So we got. What is the quotient here now? 1. Is the 1 will be the value. Next again, 3 by 2. It will be the 1, right? So what is value? 1 by 2. So what is the quotient value here now? Sorry, quotient value is 1. Quotient value is 1 here. Last and final, 1 by 2. So what you will get here now? Please remember that is 0 plus 1 by 2. So 0 into 0 is multiplied with 2. That is 0 plus 1 by 2. Therefore 1 by 2 we got. We will get 1 by 2. Therefore 1 is the quotient. Therefore we will take the 1. So that's it. So whenever you find 0 here, whenever you find the quotient is equal to 0, we should stop. We should stop. Right? Is it clear to all of you? How we have done? So therefore we have to do is that whenever you find this one, this is called A0. This is called A1. This is called A2. This is called A3. This is the procedure that we have to follow. A4. This is called A5. Right? So therefore, what is this number now? This number is we have to start from A5 to A0. That's what we know very well. So what is the number is starting from? The number is starting from 0 to higher bits positions, right? 0 to higher bits. Okay, so that's how we are going to write now. What is the decimal? What is 57 base 10 is converted into base 2 by its number 1. Please remember 1. This is the first one. A5, A4, A3, A2, A1, A0. That's it. This is base 2. Are you agreed? How do we convert this one? It is not just like in the previous decimal, any radix to decimal. Okay, but this is what the procedure that we have to follow. Okay, so please understand these points. Agreed? So if you know one concept, you can do it for any number system. So, but first of all, you have to remember very carefully the first basic conversion procedure. Okay. Now, sometimes it's very difficult to do all this doing the same kind of procedure. So we have a shortcut method is also there. Shortcut method, shorthand method, short method. What is this short method? Is that whenever we have a 57 here, 57, we have to divide that one by 2, something like this. So what is this quotient then? 28. Sorry, 28. So what is the remainder here? We have got remainder and 1. The remainder is 1. Okay, we put the remainder at the adjacent to that one. Now this one again we have to do it by 2 again. Okay, so what is the remainder here? Sorry, what is the quotient here? The 14. So what is the quotient? This is what is the quotient? What is the remainder? Remainder will be the quotient here. We can consider that. So what is that one? What is the remaining thing? 0 only. Yeah. So again we have 2 here. 2. 2 sevens are 14. What is the remainder here? 0 again. So again 2 you do it. What is the value? 3 times. 1 will be remainder. So again 2. 2 ones. What is the remainder? 1 will be the remainder. So again we have to do it 2 times. 2 to 0. 0 times it will be. What is the remainder? 1 will be. So once you find this is 0, you stop. Once you find this is 0, you should stop. And you can start from giving the numbering number position something from bottom to top. So we have to start from bottom to top. Right. So therefore, the 57 base 10 or decimal number is converted into radix 2 by 1, 1, 1, 0, 0, 1. You may ask the question, sir, how it is correct? How do we check that whether I have done correctly or not? That's also possible. So therefore, again, we have to do the reverse conversion. By looking at the reverse conversion, we can do it. How do we verify that whether I have done correctly or not? Verification. Verification. How do we do this one? As we know that, that means 1110001 must be equal to 57. Correct. That is what we can say that. How do we do this one? Just we have to do it in this way. So what is this position? 2 power 0 position, 2 power 1, 2 power square, 2 power 3, 2 power 4, 2 power 5, right? These are the positions of the bits or positions of that particular digits. So I can write this, if I multiply these quotients with weights decimal number only, we will get it, right? So therefore I will do it like this. So 1 into 2 power 5, that is the first position. Second one is 1 into 2 power 4 plus 1 into 2 power 3 plus 0 into 2 power square plus 0 into 2 power 1 plus 1 into 2 power 0. So what is value? This is 32. This is 16. This is 8. This is 0. Next 0 plus 1. So if you add all these things, it will be 57, right? By 10. So therefore this one and this one is the same. Therefore I have, whatever I have done, the procedure is the same. That is how I can verify. Agreed? I hope there is no problem at all. Very simple procedure. So either you can use this tabular form method or maybe the method, the shorthand method also you can use it. Either one is acceptable. It does not have any problem, right? Okay. So from now onwards, we are trying to do this one with the help of shorthand method only. So I want to convert 57 into, for example, radix 4. 57 into radix 4 that I want to do it. Shall we do it? Okay, shall we do? So what is the next question is, I want to convert, next bit is 57 is multiplied with, sorry, 57 of the base 10 is converted into radix 4. What is its value? Radix 4 means how many digits are there? 4 digits are there. What are those digits? 0, 1, 2, 3. That's all. Whatever the number that you specify here, that should contain only these 3 digits. Okay, possible digits, no other digits. Okay, now we do the shorthand method. What is the shorthand method? 57 base. What is the what radix that we require? Radix 4. So we have to divide this one with radix 4. Can anybody tell me what is this value? 14, right? 14 times we can do it. What is the 14 value then? 58. Sorry, 56. 4 14s are 56. Okay. What is the remainder here?
1.
1 will be the remainder. Exactly. Now I want to do it for the 14. 14 by 4. What is remainder?
2.
Sorry, what is this value? 3 times we can write 12. So what is remainder? 2.
2.
So now we have a 3 here, right? So I did not write properly. So this is 3. So again, what we have to do? 4 times 4 zeros are 0. So what is remainder? 3. 3 will be the remainder, right? 4 zeros are 0, but remaining whatever availability is there, 3 is there, then I am using the 3. So again, we start from bottom to top. So therefore, the number 57 in base 10 is equal to 321 base 4. Agreed? So we can verify also. There is no doubt at all. We can verify. So quickly we can verify. So what are the positions here? What are the positions here? 4 power 0, 4 power 1, 4 power square, right? So we can do it 3 into 4 power 4 square plus 2 into 4 power 1 plus 1 into 4 power 0. What is its value? 16 threes and Babu? 16 threes. Now, 4 square means 16. 16 threes. Chapala. A very simple problem. 16 threes.
48.
48. 48 plus 4 twos are 8. This is 1. So 1 into 4, anything power 0 is 1. No? 1 into 1, 1. Okay. So what is value? 48 plus 9. 57. So it is 57. That is right. Whatever the procedure that I have done, that is right. So this is how we can verify. We can verify. Okay. So the verification kavalante manaki em cheyali from any radix to base 10 conversion telusukoni undali. Otherwise it's not possible, right? Okay. Any other number system let us do? Octal కూడా చేద్దాం ఒకసారి. For example, octal. C. 57 divided by 57 base 10 is converted into octal. For example, 8 లో చేద్దాం. 8. So what I can do it now? Anyone from the class? Octal లో కావాలి నాకు.
8 is divided by 57.
Yeah, 57 is divided by 8. ఎంత అవుతుంది?
7 and 1.
Yeah, 7. 7 times 8 7s are 56. Remainder is 1, right? So what about this one now? That I'll use
0.
Yeah. 8. 8 zeros are 0 because it's a less number, right? So that's the reason why we have to do it with 0 only. So the remainder is 7.
7.
So we have to go from bottom to top. So therefore, 57 in base 10 is equivalent to 71 in radix 8. That's it. Right? So that is how we have to convert. Again, we can verify also. I'm not going to do that one. For example, 16, let us do it. Okay, the last problem we do it here is, in this methodology is number D. Problem number D. I want to do 57 in radix 10 into 57 in 16. By the way, 10 lo chesanu anukondi same vastundi kada manaki. Okay, same vastunda. Let us do it this one also. 57 base 10 lone kavalantunnanu, for example. It's not meaningful question, but we have to do it with the base 10. 5s, what you will have that one? 7. 10 zeros, 0. So what is the remainder? 5. So therefore the 57 only. 57 base 10. So it's not meaningful question, don't mind. But we should know any number system into any decimal number system into any radix system. E problem. So I want to do 57 of base 10 into 16. Base 16 I want to have. Hexadecimal number system also I want to convert it. Can anybody tell me what is this? 57 base 16 I need to write. How many times it can do it? 16 threes out kada? 16 threes.
16 is 48, sir.
48. What is the remainder? 9. Remainder 9 kada? Remainder is 9. Now 16 again we have to do it with 3. 3 by 16, 0. We'll have 3. So therefore, what is the value here now? The 57 of base 10 is equivalent to 39
Base
base 16. Okay, like this we can convert the base number 10 to base number 8. Fine, so far so good. We don't have any problem with this integer representations. For example, you have problem 6875 of base 10 converted into radix 2. How do I do this? Okay, the question is that so far we have seen the the left hand side 57 only we have done, but number, there is a possibility of the number having decimal fractional digits also, fractional parties also will be there. Then how do we convert this entire digital decimal number into base 2 number system? So what is the procedure now? Here is also there is a certain procedure is there. We do this one, but here we talk about the multiplication. So of course I'll do one thing for the 57 as it is. For 57 base 10 is as it is. Use division. Use the division method and get that that value. What is its value? What is its value? We have seen that 111001. That's what we have got about the radix 2 for the 57. But what about this fractional part? 0.6875. For this one, what I have to do? For this one, we have to use multiplication method. Multiplication method. Okay, how do we do this multiplication method? Let us do. Okay, so here if you do the multiplication, what is the possible number that we'll get? Integer part as well as fractional part. Okay, so what I'm going to do here is that, so 0.6, I'll use another number, color. 0.6875 is multiplied with 2. So from this one, what I want to calculate, what I want to take it integer part, and fractional part I want to get it, and fractional part. So from the integer part, I am going to calculate, I am going to take into consideration is coefficient. I want to get the coefficient from the integer part. So how do we do this one? Let us do the procedure. So if I multiply these two things, what is the value that we'll have?
1.375.
It is
375.
Yeah, 1.3750, right? Agreed? Everyone should know about this. I think this is 5 is not properly written. 3750, right? 50. So in this number, what is the integer part? 1. What is the fractional part? 0.3750, right? 3750. What is the quotient here is that, what is the quotient that we would like to do it here is that, whatever the integer part is there, that integer part we have to consider. That is the 1. This is called A-1 quotient. This is A-1 quotient. Similarly, I have to take the fractional part, remaining fractional part. The remaining fractional part is 0.3875. 3750 is multiplied with again 2. Whatever the radix that we want to convert it, we have to use that number only. Okay, if it is a 4 means 4 you have to multiply. 8 means 8 you have to multiply. 16 means 16 you have to multiply. There is no doubt. What is its value? 0.75, something like this. Okay, if you multiply this 0.3750 is multiplied with 2, are you getting this one 0.75? If you have a calculator, please try to do it. What is integer part? 0 only. We have 0 only. What is the decimal part? 0.75 only. So this integer part only I need to take it to consideration. So, oh my God, battery is running low. So what is this value then? Integer part is 0 only. So that is actually a minus 2. Similarly, what is the fractional part, remaining fractional part? 0.75 is multiplied with 2. Is multiplied with 2. What you will get then?
1.5.
Yeah, exactly. 1.5. So what is integer part in it? 1. What is the fractional part in it? 0.5. So what we have to consider? Integer part. Integer part is 1. This is nothing but a minus 3. So what we have to do is the next one. Still we have to go to 0. Integer part is 0. Yeah, the complete version is 0. Then only we have to stop. Okay, so I will tell you that one also. So now the fractional part is 0.5 is multiplied with 2. Sorry, the fractional part should be 0. What is its value? 1.0. So what is integer? Is the 1. What is the fractional part? 0. So whenever you find 0 is the fractional part, we should stop. When the fractional part is equal to 0, we should stop. So therefore, this is what actually we are taking into consideration. This is called 1. Therefore, this is a minus of 4. Right? This is what the procedure that we have to follow. Okay. Now, how the number positions that we have to take? We should take from top to bottom. We should take from top to bottom. So therefore, 0.6875 of base 10 is converted into 1011 into base 2. Therefore, totally what I can do it now here is that, therefore, 57.6875 of base 10 is converted into, what is this the number? 111001.1011 base 2. So this point is called binary point. I want to name binary point. So we talk about the binary related information later point of time, but we normally talk about binary point. So whether this is correct or not, how do we verify? Yeah, again, we have to start in this way. So I don't want to explain that one more detailed. 2 minus 1, 2 minus 2, 2 minus 3, 2 minus 4. This is 2 power 0, 2 power 1, 2 power square, 2 power 1. Sorry, 2 power 3, 2 power 4, 2 power 5. So just we have to multiply everything, right? I hope the concept is clear to all of you. Okay, just what simply I can write this one for verification. For verification. So 1 into 2 power 5 plus 1 into 2 power 4 plus 1 into 2 power 3 plus 0 into 2 power square plus 0 into 2 power 1 plus 1 into 2 power 0. Are you getting what I'm doing here? So this is what I have done. Now fractional part. 1 into 2 power minus 1 I have to write. Next plus 0 is there. 0 into 2 power minus 2 I need to write. Plus 1 into 2 power minus 3. Plus 1 into 2 power minus 4. So we have to add all these things. You will get the 57.6875 only. You will get it there. Right? So the same thing is applicable for radix 4, radix 6, something like that. But by the way, I want to write the shorthand notation. Of course, the tabular form is somewhat difficult to write all the time. So I'll go for shorthand notation, shorthand, short method. For example, 0.6875 is multiplied with 2. Immediately you write that, what is the value that we'll get? 1.3750. 1.3750. So therefore, from this one, use this integer part, 1. What is the remaining part? 0.3750 is multiplied with 2. What is this value? 0.75. So what is this integer part here now? 0 only. Therefore, 0 you write. This is 1. 1 you write. Again, 0.75 is multiplied with 2. What you will get there? 1.50. So therefore, that is called, what you will get here now? 1. 1 will be the answer. What about the remaining things? 0.50 is multiplied with 2. What you will get? 1.0. So this is 0. 1 will be accepted. So we have to start from bottom to top. Therefore, 1011 will be the base point of this one. Please remember that. One point we have to remember that it is not all the time to get 0. Okay. So maybe 10 times or 10 iterations, maybe 12 iterations, it will be go. But minimum at least 4 to 5 digits multiplication that we have to do. 4 to 5 multiplications. It is not all the time to get here in this particular example, we got quotient is equal, fractional part is equal to 0 after 4 multiplications. Sometimes it is not, you won't get 0 after 10 multiplications also. In that situation, we have to take 4 to 5 multiplications. Agreed? Okay. So therefore it is recommended. Note, let us write note here. It is recommended to do at least 5 multiplications. If fraction is not 0, fractional part is not 0. Okay. So that's what you have to remember. Fractional part is not 0, then only you have to do this one. Otherwise, fractional part 4 times was taken. Otherwise, at least you have to take in that manner. Okay. I hope you understand the concept here. There is no doubt at all. Okay. So do you have any problem related to this one? Can you do it for the same fractional part related things for any other number system? Please try to do it in your home. Please try to do it in your home. Same 0.6. So, okay, example. So, homework. What the homework is? 0.6875 of base 10 into base 4. I need to have base 4. Please don't neglect to do this one. Sorry. Okay, base 4. Base 4 and base 8 and base 16. You have to do this one. So what is its value, fractional value for in this particular number system? Same thing. Only thing is that instead of the multiplication of 2, we have to use multiplication by 4, multiplication by 8, multiplication by 16. Okay, if you got fractional part after some multiplication 0, it's okay. Otherwise, you have to do at least 5 to 6 multiplication. Sorry, 4 to 5 multiplications. Okay, so with this, we have come to the end of the today's session. If you have any problem, we will discuss. Any doubts are there, then I will discuss. Otherwise, we stopped here today. Okay, we talked about today is the conclusion is that we have done decimal number system. We have done the conversion from decimal to any radix. Okay, so we stop here today, and the remaining things we will see in the next class. Please, all of you, please watch this. All of you, please. So you can leave now.
Okay, sir. Thank you.
Thank you, sir.
Thank you.